Find the domain. Well, domain means that we are looking for the x values that we can use. So what x values can we put into this function? Sometimes it's easier to say what you can't use and then say you can use everything else. So for this one, we have a special consideration, and that is we cannot have 0 in the denominator. 0 in the denominator would be undefined, so we know we can't do that. So that's going to be a restriction, which means we need to figure out where our denominator would equal 0, so we can say that our domain is everything else. So if we simplify this is a difference of squares. So we can split this into x minus 4 times x plus 4. If we do that, we get x minus 4 equals 0, and we get x plus 4 equals 0, which means that x would equal 4 and x would equal negative 4. So our domain, we're going to say, is everything else. So we're going to say x cannot be negative 4 and 4. So the domain would be all other values. Now let's look at part A. In part A, we're asked to find the limit as x approaches 2. 2 is in our domain. So that means our function is continuous at 2, so we can use direct substitution. Remember, continuous means that we can draw our function from the left to the right without picking up our pen any way along the line. So it means that it is continuous everywhere if it's continuous over the interval. So our function here is continuous at 2 because our points of discontinuity, our points that are not in the domain, are negative 4 and 4. So that means we can do direct substitution. So that's going to look like 2 squared minus 2 times, take out our x, put in our 2, minus 8. All over, we have 2 squared minus 16. We can simplify this down, and that looks like in the numerator, it's going to give us negative 8. And in the denominator, it's going to give us negative 12, which will simplify to 2/3. So that means our limit as x approaches 2 is going to be 2/3. Now in part B, we're asked to find the limit as x approaches 4. Well, this gives us a little bit of a problem because 4 is not in our domain. So our function is not defined at 4. But what's happening as you get very close to 4 on either side of 4, that's what we mean by the limit. So in order to figure this out, we need to try to do some simplifying. We can't have division by 0. So we need to make it so we don't have 0 anymore in the denominator if we are to put in a 4. So what you can do is you can factor. If we factor our numerator, I'll give you a hint. You want to have either x minus 4 or x plus 4 as a factor so that you have a common factor with the denominator. I'll show you why. So if we factor our numerator, we can factor this as x minus 4 and x plus 2. Negative 4 times positive 2 gives us negative 8. X times 2 is 2x. Negative 4 times x is negative 4x. So that works. And then in the denominator, we will still have our x minus 4 and x plus 4. The good news is these two will cancel, which means we're going to now be able to evaluate the limit as x approaches 4 of x plus 2 over x plus 4. Now we don't get 0 in the denominator anymore. If we substitute in our 4, we have 4 plus 2. Substitute in our 4, we have 4 plus 4. 4 plus 2 gives us 6. 4 plus 4 gives us 8. And then if we simplify our fraction, we get 3 over 4. So the limit, not the value at 4, the limit as x is approaching 4 is going to be 3/4. The value at 4, that one's undefined. It's going to be a hole in our graph because 4 is not in our domain. Let's look at number 5. Number 5, are there any restrictions? No restrictions. So we can do direct substitution. So we'll have 4 times negative 2 squared plus, and then we have negative 2. So if we simplify this down, negative 2 squared is 4. 4 times 4 is 16. Minus 2, we get 14. Let's look at this one. We have a denominator, but that's okay. We do not have 0 in the denominator if we substitute our 5 indirectly. So that means we can do direct substitution again. So we'll have 3 times our 5 squared plus 1. W gets replaced with 5. It doesn't give us 0 in the denominator, so we're okay. 5 squared is 25, times 3 is 75, plus 1 is 76 over 5. I'm just going to leave it as a fraction. We don't need to change it over to a decimal. We can leave it. Now let's try this one. We have another complicated where we might have division by 0. So let's put it in, let's see what happens. If I put in -1 to the 4th minus 1, that is 0. So that's a problem. So we need to try again to simplify this down and see if we can eliminate our division by 0. So let's see if we can do some factoring. Well, in the numerator, we can factor this to x plus 1 times x plus 1. -1 is not in our domain, so we need to factor the denominator and see if we can get rid of an x plus 1, hopefully with a common factor in the numerator, to change it to be able to simplify by direct substitution. So let's do some factoring. These are the difference of squares. So x squared minus 1 times x squared plus 1. So this one will be okay. X squared plus 1. -1 squared will turn into +1 plus 1 is 2. So we're making progress. But this one is still not okay because we'll have -1 squared is 1, minus 1 is still 0. But luckily for us, that is still factorable. So let's keep factoring and see if we can make it a little better. So let's keep our numerator. So we have our x plus 1 times x plus 1 in the numerator. And let's factor. This is the difference of squares again. So that gives us x plus 1 times x minus 1. And this factor was okay. So x squared plus 1 right here. Now we can cancel a common factor. So this makes it able to be simplified now. So if we cancel a common factor, now we don't have any restrictions because when we substitute in our -1, it's not going to be 0 anywhere anymore. No, it's not going to be 0 anywhere in the denominator anymore. When we put in our -1 in the numerator, we get -1 plus 1 over, this one's canceled. So now we have -1 minus 1, and we have -1 squared plus 1. Be very careful. -1 plus 1 is 0. Very true, but it's in the numerator, so that's okay. In the denominator, we're going to get -2 times 2. So 0 over -4, that's 0. It's okay to have a value of 0. It's not okay to have division by 0. And this right here, we need our limit as x approaches -1, so that we know we did our direct substitution there. In part D, we have more special limits. So let's see if we can evaluate these to take into consideration our special limit values. So look at the top one. If I put 0 in part D, we're going to get division by 0. Right here, if I substitute in 0, we're going to get division by 0. We know we can't have that. So here we have to multiply by what's called the conjugate. It looks a little tricky, but let me show you how it works. So this means that we multiply by almost the same thing, the square root of 1 plus h plus 1 over the square root of 1 plus h plus 1. Notice the -1 from the original right here, and notice the plus ones from the conjugate. Watch what happens. If you do your FOIL, so multiply your numerators and then multiply your denominators. If you do the FOIL, you have the square root of 1 plus h times the square root of 1 plus h. That is just 1 plus h. Then you're going to have the square root of 1 plus h times +1. That is plus the square root of 1 plus h. Then you have -1 times the square root of 1 plus h. So that's minus the square root of 1 plus h. And then you have -1 times 1, and that's -1. All over Don't worry about simplifying this out. Just leave it as h times the square root of 1 plus h plus 1. These will cancel. So that means we're left with this one and this one. So we have h over h times the square root of 1 plus h plus 1. Be careful with your square root that you don't extend it too far. Now look, these will cancel. So in the numerator, we're left with 1. And in the denominator, all of this boils down to the square root of 1 plus h plus 1. And now when we put in our 0 right here, or our h right here, we'll have the square root of 1 plus 1 in our denominator. So all that becomes, the square root of 1 is 1. So 1/2. Let's try part E. Part E is looking like we should factor. I see some squares, I see some common factors. So let's go ahead and factor. I'm going to pull out an x from the top because the common factor right here is x squared minus 4x. Common factor is an x. So that means I'm hoping to get an x or an x minus 4 from the bottom. Looks like x minus 4 is more likely. So let's see if we can factor this. If I want an x minus 4 and I have a minus 4 here, that means I'm going to need a plus 1 and a minus 4. So let's see if it works. X times x is x squared. X times 1 is 1x. Minus 4x, so that's minus 3x. Minus 4, we got it. But look, these are going to cancel. So that gives us x over x plus 1. So we can evaluate the limit as x approaches 4 by doing our substitution. So that's going to give us 4/5. And the last one, part F. If we substitute in our -4 right here, we're going to get division by 0, and we know we can't have that. So we need to modify it. So let's see if we can clean up these fractions. If we get a common denominator of the numerator, it would be 4x. So we need an x for the first fraction, and we need a 4 for the second fraction. So that is going to look like x plus 4 over, both of the denominators are 4x, so we can combine them, all over 4 plus x. I like to put it over 1 so I can see the complex fraction a little bit more easily, but you wouldn't have to. Now, when you have this complex fraction, you take the bottom fraction and you flip and multiply. So 1 over 4 plus x. So let's rewrite this so we can have it a little bit more cleanly. So we're going to have the limit as x approaches -4 of x plus 4 over 4x times 1 over 4 plus x. Now we know the commutative property holds for addition, so we can rearrange this and make it x plus 4 if that's more comfortable. Then these will cancel, and it looks like we're left with the limit as x approaches -4 of 1 over 4x. Well, it's not going to give us 0 anymore, so now we can put in our -4. That's going to give us 1 over 16. Technically, it's -16. I like to leave the negative in the numerator so I don't overlook it. So it'll look like that.